All right, good evening, morning, midnight, whatever time it is you are watching this video. So for week 4, we are doing our last lesson of chapter 7. So next week, week 5 of online learning, we will be reviewing and taking a test over chapter 7. I'm not quite sure how the test is going to look like right now, but I assume it will look like all the quizzes we've been doing. So it'll be on Alex, and you'll have to do a flip grid over one problem. I'll probably randomly assign a problem like I did for this lesson, okay, or for this week. Okay, so parametric equations. We've done this back in the trig section, and so some trig is going to come back, I know. And it's okay. So the definition of a parametric equation, I'm just going to do bullet points for today. So x and y are defined in terms of some other variable, okay? And most of the time that other variable is t. So we're gonna define them in terms of t. When we did parametric equations with sine and cosine, we did theta, but it's the same thing. It's just they're both defined in terms of some other variable. Normally when we have equation, x is defined in terms of y and y is defined in terms of x, right? Y equals 2x. So I know the y value is double the x value, all right? Okay, t is what we call the parameter, and that is because x and y depend on t. And t is usually, not always, but almost always, is usually on a restricted domain or interval. Okay, so t is usually on the restricted domain or interval. So we'll have t goes from -2 to +3. Or if we're going to do it in terms of trig, it'll go 0 to 2 pi, things like that. Okay, and we will use parametric equations. So their purpose, most of you probably have seen this if you've taken a physics class already. Very useful in physics, okay? So we will use them to define non-function graphs. All right, oops. Hopefully you've noticed, besides some of the parabolas, every other conic section is not a function, right? So a function passes the vertical line test, right? Every input has exactly one output, okay? If I were to draw a circle, or an oval, sorry, that's an oval, and I did my vertical line test, that definitely does not pass, right? Same thing with a circle, okay? Even if you did like a hyperbola, right? That's not gonna pass at all, okay? The entire thing isn't a function, all right? And same, even the sideways hyperbola, okay? That doesn't pass because right here and right here, okay? You got more than one output for an input, all right? So we're gonna use this so we can define our non-function graphs, okay? And we can graph them. And the really cool thing is they show direction of a graph throughout time. Okay, and so what that will look like is, say we're gonna have this circle, I'll do my best. Okay, we are gonna have a starting point on the circle, and we're gonna show that the circle is rotating this way, okay, and then this will be the ending point. All right, so that's what we're going to be doing with parametric equations also. So we're not only going to define things that aren't functions, okay, all of our conic sections. We're also going to show the direction we're rotating or the direction we're going down a line or anything like that. Okay, just a little review from trig. I will post a blank unit circle if you lost yours so you can print it out. This will come back a little bit. So we know x is equal to r cosine of t. When we did it, we said x equals r cosine of theta. Same thing, okay? Just theta and t are switching, okay? And y is r sine of t, okay? Or as we did it, it was y equals r sine of theta. All right, so what this really is this set right here, that set of equations is the equation for a circle. All right, so that is the parametric equation for a circle. You guys learned that a circle is x squared plus y squared equals r squared. All right, but the equation for a circle in terms of parametrics is x equals r cosine of t and y equals r sine of t. All right, and usually t would be on the domain 0 to 2 pi. All right, so that's just the basics for this, and we got 3 different examples, so this one's actually going to be a pretty short lesson.